Hello everyone. Thank you for watching the video today. In this video, we're going to do an introduction to sequences. In this unit, we're going to talk about sequences and series, but for now, we're just going to focus on sequences. Okay, so first of all, what is a sequence? An ordered list of numbers, a relationship or function in which the domain is a set of natural numbers. In general, a sequence is a pattern or an ordered list of numbers. Each number in the sequence is known as a term. A finite sequence has a finite number of terms and then stops. An infinite sequence goes on forever. For a sequence, the number of the term is represented by some number n. The value of that term we'd say is a sub n. That's how we would say that, a sub n. So down here, consider the sequence defined by this formula. What does a sub 10 mean? It means to find the 10th term in the sequence. So here's some examples, and really at any point in this video, if you want to pause these examples and try them on your own before I go through the answers, you're welcome to do so. All they are is pattern recognition right now. So feel free to pause the video and try all these sequences on your own at any point. Okay? If not, if you want to take a look at what I'm doing, that's absolutely fine. Here we go. Let's take a look at A. So we got the first four terms. We're trying to find the next four terms. It looks like we're just dividing by 2 each time. So the next four terms would be 2, 1, 1/2, 1/4. Let's see the next one. We're adding 1, adding 2, adding 3, adding 4, adding 5, adding 6. Now we're going to add 7, add 8, add 9, and add 10. Example 2, write the first 4 terms of each sequence out. All right, so here we have a formula for a sequence. I want to find the first 4 terms. If I find the first term, I'm just going to put 1 in there. I get 2 plus 7, which is 9. For the second term, I put 2 in here. I get 4 plus 7, which is 11. Put 3 in for n. You get 6 plus 7, or 13. And put 4 in for n. You should get 15 back. Okay, b sub n. So b sub 1 would be 1 squared minus 4. b sub 2 would be 2 squared minus 4. b sub 3 would be 3 squared minus 4. And b sub 4 would be 4 squared minus 4. C sub n. C sub 1 would be 2 to the first, I'm just going to write this one out here, plus 1 squared, which is 2 plus 1, which is 3. Sometimes they're a little bit more complicated than doing them in your head. All right, C sub 2 would be 2 squared plus 2 squared, which is 4 plus 4. C sub 3 is 2 to the third plus 3 squared, so 8 plus 9. And C sub 4 is 2 to the fourth plus 4 squared, which is 16 plus 16. So 32. D sub n. So D sub 1 would be negative 1 to the first times 1 plus 4, or negative 5. D sub 2 would be negative 1 squared times 2 plus 4. D sub 3 would be negative 1 to the third times 3 plus 4. And D sub 4 would be negative 1 to the fourth times 4 plus 4. And you can kind of see the pattern developing there. E sub n, E, which we're going to do a sub n again. So a sub 1 would be 1 plus 1 over 2 plus 1. A sub 2 would be 2 plus 1 over 2 plus 2. A sub 3 would be 3 plus 1 over 3 plus 2. And a sub 4 would be 4 plus 1 over 4 plus 2. There's our first 4 terms. And finally, f. So a sub n would be 32, sorry, a sub 1 would be 32 times 1/2 to the first, or just 32 times 1/2, which is 16. A sub 2 would be 32 times 1/2 squared, which is 1/4. So that's 8. A sub 3 would be 32 times 1/2 to the third, or 1/8. So that's 4. And a sub 4 would be 32 times 1/2 to the fourth, or 1/16, or 2. And you can kind of see how that pattern is developing there as well. Example 3, given this sequence, a sub n here, find the ninth term, the n minus first term, and the n plus first term. So for the ninth term, we're going to write a sub 9 equals 9 over 9 plus 2. So a sub 9, looks like a Q, doesn't it? It's a 9. A sub 9 equals 9 over 11. Well, the next two, don't do these any differently. You're just going to put n minus 1 in for n. So a sub n minus 1 equals n minus 1 over n minus 1 plus 2, which is n minus 1 over n plus 1. And for a sub n plus 1, need to see the sequence there. It'd be n plus 1 over n plus 1 plus 2, which is n plus 1 over n plus 3. All right, there are 3 different types of patterns that we should be able to recognize pretty quickly when we look at these here. The first one's a linear, and what does that mean? It means that the first difference is going to be constant. All right, so our first difference is constant. All right, so what do we mean by that? So here's an example of a linear term. 5, 8, 11, 14, 17, so forth and so on. Notice how each one's changing. I'm adding 3, adding 3, adding 3, adding 3, right? The difference is the same each time. A quadratic one. That one, the second difference is constant. What do I mean by that? Let's do an example of this one. So example, this one would be like -2, 1, 6, 13, 22. I'm not just coming up with the top of my head. I have examples of these ready to go. So second difference means, well, first difference here is 3, 5, 7, 9. But then the next is 2, 2, 2. So the second difference is the same each time. The third one, exponential, we also call this geometric. We'll talk about that soon. And we also call linear arithmetic. We talk about that soon as well. All right, but geometric or exponential has a constant multiple, or we call it a ratio. All right, so an example of that would be 6, 12, 24, 48, 96, and so forth and so on. So for this one, we're multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2 each time. So those are 3 patterns that we see a lot in sequences. All right. The last thing we're going to talk about today is, if you're given a sequence, can we write a formula for it? Sometimes this is very simple. Sometimes it can be pretty complicated. So really, you just want to think your way through these as much as possible. All right? So the first one, you should hopefully recognize this as linear, right? And how do I know it's linear? Well, look at, we're just going down by 3 each time, right? Down by 3, down by 3, down by 3. So I know that this sequence is going to be a sub n equals -3n something, okay? Now, if I thought about the slope of this line, I get -3. Now, what I can do here is I can put some points in, like for example, 1, 7 would be a point, right? So if I just wrote a line out here, it'd be y minus 7 equals -3 x minus 1. And by minus 7 equals -3x plus 3, y equals -3x plus 10. Okay, so -3x plus 10 would be our line, so then our sequence here would be -3n plus 10. That would be what we call our explicit formula. We'll talk much more about this as we go. It's our explicit formula, or our general formula, or our nth term formula. Okay? Second one, hopefully we recognize this. This is just a pretty basic quadratic, right? It's just, how do I know it's quadratic? Well, I'm going up by 3, and then 5, and then 7. So my second difference is 2 and 2, the same each time. That's how I know it's quadratic. And this is just the perfect squares. So don't overthink this. A sub n is just going to be n squared, right? 1 squared, 2 squared, 3 squared, 4 squared. So this is our nth term. For C, a sub n, well, the numerator is always 1. So that's just going to be 1, right? The denominator is going up linearly, 3, 7, 11, 15. So again, that has a slope of 4. So I can do what I did in part A. Let's see if I just use my first term here. So y minus 3 equals 4 times x minus 1. So I can write this as 4n minus 1. And that would be my nth term. Now, very soon, I will teach you a formula that will help you come up with this a lot quicker. But for now, that's the best we can do. All right, questions. We got 2 more here, right? Question D. So this one we would call geometric, or as we called it earlier, exponential. But in the sequence world, we call it geometric. We're multiplying by 2 each time, right? So what we're going to do here is we're going to go a sub n equals 2 to some power. Let's call it n, all right? But we're going to subtract 1 from it because the first term, I want this to basically cancel out and multiply it by the first term, which is 3, okay? So now let's check this. If I put 1 in, this would be gone, and we get 3. If I put 2 in, I would get 2 to the first, which is 2, times 3, which is 6. If I put 3 in, I would get 3 minus 1, which is squared, so 2 squared is 4 times 3, 12. So this is going to work. And again, I'm going to teach you a much easier way to come up with this formula very soon, but for right now, I'm just trying to get you to recognize patterns. Okay, our last one, E. The numerator is going up linearly, so let's do the numerator first. Okay, if I did y minus 5 equals, the slope is 3, x minus 1. So y minus 5 equals 3x minus 3, y equals 3x plus 2. I know that my numerator is going to be 3n plus 2. All right, now let's talk about the denominator. The denominator is just the powers of 3, right? 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. So that's just going to be 3 to the n. And that is our nth term for sequence E. Okay, that's it for our first lesson in sequences and series. Hope to see you again soon.